whatever happened on Earth, it's not likely to be rare or unique, because carbon chemistry, on which life is based, is the most fertile kind of chemistry there is. Carbon is abundant across the universe. So if there's life somewhere else, it's probably based on carbon. It's a fascinating bias, but it's not an unjustified bias. And the universe has been around 14 billion years, plenty of time to evolve all manner of creatures out there, particularly microorganisms. We have no reason to not think of microorganisms as aliens. They don't have to have built a ship. There's just alien life on another planet.
The origin of life is one of the great mysteries in the universe. It is perhaps the most fundamental and at the same time the least understood biological problem. Science remains undecided and conflicted as to the exact origin of life, and there may be many hypotheses on the possible ways that life might have begun. The prevailing scientific hypothesis is that life began solely with RNA, a close cousin of DNA. The transition from non-living to living entities was not a single event, but an evolutionary process of increasing complexity that involved the formation of a habitable planet. Many scientists think that RNA, or something similar to RNA, was the first molecule on Earth to self-replicate and begin the process of evolution that led to more advanced forms of life, including human beings. The earliest life forms we know of were microscopic organisms that left signals of their presence on rocks about 3.7 billion years ago. With an environment devoid of oxygen and high in methane, for much of its history, Earth would not have been a welcoming place for life. Evidence suggests that our planet was inhospitable to life for the first 700 million years, bombarded by asteroids and comets. Hot lava streamed into the atmosphere and was then spewed all over the planet. Because of the enormous length of time and the tremendous change that has occurred since then, much of the evidence relevant to origins has been lost, and we may never know certain details. Nevertheless, many of the gaps in our knowledge have been filled in recent years, and continuing research and new technologies hold the promise of more insights. By studying the basic biochemistry shared by many organisms, we can begin to piece together how biochemical systems evolved near the roots of the tree of life. Some of today's most brilliant minds are actively considering whether life got to Earth from elsewhere in the universe.
We learned that asteroid impact, when they hit, can cast rocks in the surrounding areas into space with escape velocity, so they never come back to the planet from which it was launched. If Mars was wet and fertile before Earth was, as all evidence suggests, and if Mars had life before Earth had life, it is possible for there to have been bacterial stowaways in the nooks and crannies of the rocks that were cast into space. There's some hardy bacteria that we already know exists on Earth. Survives extreme temperatures, pressures, freeze-dry, reconstituted, radiation. The hostile environment of space would be nothing to some of these bacteria. It may be that life on Earth was seeded by bacterial stowaways on rocks that were cast free from Mars. This is a plausible scenario that's called panspermia, the transference of life from one planet to the next.
The idea is that life would form in one place across space and then by some mechanism or other transfer from that place, where it formed, to another place. This leads to the question whether living organisms have been transported between the planets of our solar system by the same mechanism. Many astrobiologists now think that Earth was seeded with life by comets and asteroids.
Life on Earth is hydrogen, oxygen, carbon. This stuff is everywhere in the cosmos. It's a huge universe. We're made of very common ingredients. If you want to believe that life on Earth is the only life in the universe, in a way that's kind of inexcusably egocentric. There's no accounting for that attitude, unless you have some sort of philosophy that requires it of you, but it's not based in data or evidence. So I want to look for life. And life on Earth, if we use that as a starter kit, thrives in liquid water. So if you want to find life, let's look for liquid water out there. And so we know Mars has all this evidence of once having had liquid water. We think it's submerged and now in a permafrost. And maybe if the pressures are high enough, some of it might have been liquefied, creating aquifers. Recently, we found methane emerging from one of the cliff faces of Mars. Methane. You can make it without biology, but biology kind of does it for free with sort of anaerobic microbes, the kind you find deep in the digestive tract of farm animals. One of the moons of Jupiter, Europa, is kept warm. It's way outside of the green zone, that zone where this Goldilocks zone, where the temperature is just right. Because if you're too close to the sun and you have liquid water, you evaporate. Too far away, you freeze. So there's a zone where it's just right, where it's liquid. This Europa is well outside of this green zone, this Goldilocks zone, yet there's an ocean of liquid water, been liquid for a billion years. Turns out the gravitational stress of Jupiter on that moon, combined with stresses triggered by other moons, is pumping energy into that orb. And when you do so, where does the energy go? It melts the ice.
All DNA and RNA, which contains the instructions to build and operate every living being on Earth, contains 5 informational components called nuclear bases. Recently, scientists at NASA discovered that all of these bases in DNA and RNA have been found in meteorites. While it is unlikely that DNA could be formed in a meteorite, this discovery demonstrates that these genetic parts are available for delivery and could have contributed to the development of the instructional molecules on early Earth. The discovery gives more evidence that chemical reactions in asteroids can make some of life's ingredients, which could have been delivered to ancient Earth by meteorite impacts, or perhaps the infall of dust. Earth is the only place we know of so far that's inhabited by living things. It is the only world in our solar system with liquid water on the surface. Scientists are exploring several possible locations for the origin of life. One hypothesis is that life originated near a deep-sea hydrothermal vent. The chemicals found in these vents and the energy they provide could have fueled many of the chemical reactions necessary for the evolution of life. Furthermore, during the DNA sequence of modern organisms, scientists have tentatively traced the most recent common ancestor of all life to an aquatic microorganism that lived in an extremely high temperature, a likely candidate for a hydrothermal vent inhabitant. Does this mean that our beloved planet is the only planet in the universe that supports life? Although several lines of evidence are consistent with the hypothesis that life began near deep-sea vents, it is far from certain. The investigation continues and may eventually point towards a different site for the origin of life. According to Tyson, to think that we are the only place where life found its way would be arrogant. So far, the search for a truly Earth-like world has turned up empty.
There is this zone around any star where if you are too close, then liquid water would evaporate. If you're too far away, then your liquid water would freeze. And water being so crucial to our understanding of life as we know it, if you're going to look for a planet in search of life like us, you would look for planets in the habitable zone. And I think of it as the Goldilocks zone. And if a star gets hotter, it'll still have a Goldilocks zone, it'll just be different.
We've found more than 5,000 exoplanets and we're still alone. But will we know life when we see it? The James Webb Telescope could get the first glimpses, the mix of gases in the atmospheres of Earth-sized exoplanets. Webb, or a similar spacecraft in the future, could pick up signs of an atmosphere like our own. Oxygen, carbon dioxide, methane, a strong indication of possible life. Future telescopes might even pick up signs of photosynthesis, the transformation of light into chemical energy by plants, or even gases or molecules, suggesting the presence of animal life. Intelligent, technological life might create atmospheric pollution, as it does on our planet, also detectable from afar. Of course, the best we might be able to manage is an estimate of probability. Still, an exoplanet with, say, 95% probability of life would be a game changer of historic proportions. Thanks for watching. Did you like this video? Then show your support by subscribing and ringing the bell to never miss videos like this.